Good afternoon everyone, my name is Jose Ignacio Escalera Aramburu, and today I'm going to show you my project, which is a stable and monostable signals, and the main topic is the elements in an electronic circuit. So let's begin. First of all, we have to understand what the project consists. It used the stable and monostable signals. So basically the stable and monostable signals are these ones, and the stable signals are the ones that oscillate in zeros and ones. But oscillating, I mean when changing from the ones to the zero in a period of time. This is the total period of time, okay? And this is the 1, this is the 0, 1, 0, 1, and so on. There are two different types, which is this one in a boxy signal, and then we have the crocodile tooth, which is like this, like spikes, if you want to see it like that. And it oscillates in any kind of voltage that you want to input, and then it goes to the zero or the voltage that you want. And then we have the monostable signal. The monostable signal, it's kind of different because in this case stays on the zero, and then when activated with the voltage changes to the 1, but as you can see stays like that for a period of time and then resets itself to the 0. Okay, so that's the basics of the project, the stable and monostable signal. For the components of my project, I used resistors, and in this case you can use any value of resistors and you'll see why in a bit. Capacitors, you can use electrolytic, or you can use in this kind of capacitors, and of course you can use any value of capacitors, you'll see why again. The multivibrator 555, which is the one that gives us the alternary signals, the push button to activate the voltage, and an output device, which is any kind of device or electronic or component that you want to use to see the signals or the behavior of the signal. I use LEDs. So the function of my project, it consists on stable signals and monostable signals, and uses the multivibrations from the 555, and you can see here in the graph that I have the crocodile tooth, and it oscillates from the 0 to the 1 and returns itself every time, and it's on the 5 voltage and then to the 0. Okay, and then I also did the monostable signal. I did two circuits, sorry. In this case it stays on the 0 and then goes to the 1 for a period of time, as you can see here, and it returns to the 0. Okay, so using the Kirchhoff law, you can see that it has many meshes and many nodes, like here 1, 2, 3, 4, 5, 6, 7, and so on. And here in the meshes, if we use a node, you can always use this one when analyzing the circuits. You have to always use the negative. You can see that it goes over here. This one is not a node, then goes here, over here, and this one is one mesh, goes clockwise. And here, over here, we have another mesh which goes clockwise again, and then from here, over here, goes again in a clockwise motion. Okay, so for the stable, it's kind of the same. You always start by using the node over here from the negative, and you go over here and analyze every kind of mesh. We have one here, we have one here, and one here, and the nodes again 1, 2, 3, 4, 5, and 6, and so on. Okay, so as I said before, you can use any kind of resistors. In this case, I used a variation of resistors and capacitors because the time changes with the values of the resistors and capacitors. Again, you can use any variation. It will give you any different kind of time, and you can calculate it using these formulas. Okay, and then the uses and applications for my project, you can use it for a light lamp, for motors to activate them, and pulse generation, and also for this kind of signal you can use the oscillator to calculate it. And this is my final product. As you can see, I have LEDs over here. I use capacitors, the multivibrator, the push button. So here is one, here is the another one. So basically this is the monostable one and this is the stable one. You can see over here in the pictures the astable, because it has the push button, and the astable. Sorry, this is the stable and this is the monostable. Okay, so I really hope you like my project, and I really hope you understand this information. So thank you very much.